Hi guys, in this video we'll be looking at electron microscopes, transmission and scanning electron microscopes, a microscope summary, and then we'll finish with a summary. So electron microscopes work slightly different to the way that light microscopes work. So instead of using a beam of light, as in light microscopy, they use electrons or a beam of electrons to study the specimens instead. And this gives them slightly better properties. So here we've got the two contrasting systems and how they work. On the left we've got a light microscope, whereby we've got visible light being shone from a light source through various lenses through the specimen and to our eye. In the case of an electron microscope, we've got a beam of electrons which shoot through the specimen and again get scattered to a detector and then to our eye. So they use different types of radiation. The electrons that are used in these type of microscopes have a higher wavelength or a shorter wavelength than visible light. So they can be used to create higher resolution images, and they're in more detail, and we call them the micrographs. So here we've got the section of an image from a light microscope machine, but here we've got two images from electron microscopes, and you can see that the detail and the amount of resolution is a lot greater because of the use of electrons. And again, this is because the wavelength of visible light is longer than that of the electrons. So we need to discuss the two different types of electron microscope, which are scanning electron microscopes, or SEM, and transmission electron microscopes, TEM. And they're very large machines. But in both types, a beam of electrons is focused by a magnet towards a specimen. So looking again at this model, we've got a source of electrons and a beam of electrons, and various different magnets are focusing the beam into a very specific orientation. And then right at the bottom we would have our specimen here, the red dot, and eventually this will be detected and we can form an image. The specimens also need to be stained or coated with often a metal and then placed in a vacuum, a space where there are no particles even in the air. So we can see a coat of metal around this, for example, fly specimen. Because we have to coat them and place them in a vacuum, the cells will be dead because they cannot survive in a vacuum or being coated in metal. So electron microscopy only views things which are dead as opposed to living. So let's distinguish the two types of electron microscope. In scanning electron microscopy, the electron beam hits the specimen and then it gets scattered onto a detector. So visualizing that here, we've got our electrons being fired from the source, and as they get magnified and put through magnets, they eventually hit the specimen. And you can see that the electrons get scattered in various directions. And the purpose of this scattering is that the microscope image can then be 3D, because the different orientations where electrons land are scattering in various directions, and based on where they arrive we can tell how far away it was and therefore build up a 3D image. So the benefit is we see things in 3D, but the resolution is quite low, and so is the magnification. So it would be great to see a general structure and how tissues arrange themselves in 3 dimensions. However, the downside of this is that the resolution and the magnification are both low. In transmission electron microscopy, or TEM, the electron beam travels right through the specimen and then the detector is below. So this time we have a very similar setup where we have our electrons passing through with the magnets, but this time the specimen is placed here, and remember the specimen for both of these types has been coated in metal and put in a vacuum. The electrons pass through the specimen and get to a detector which is here. So this time the detector is underneath. And the benefit of this is that we get a higher resolution, so we get more detail and a higher magnification compared to scanning electron microscopy, but this time we only get a 2D image because it's gone straight through in the same orientation. So we can say that this one has a lot more resolution and magnification, but the downside is that it is 2D as opposed to being 3D. However, this might be useful in certain situations. So here's just a table to summarise the two types of electron microscopes: scanning electron microscopes and transmission electron microscopes. They both use an electron beam. Scanning can give us a 3D image, but transmission is 2D. But the 3D images are of a magnification of just times 200,000. The 2D image, although it is only 2D, it can be 2 million magnification. The resolution on the 3D one is also lower at 20 nanometers, but on the transmission electron microscope it's 0.1 nanometers, so a lot more magnification and a lot more detail. So here's just a summary of the different types of microscopes that you might see and the ones that we've been through. So let's talk about the light microscopes first. The light microscope and the laser scanning microscopes use a light beam both together. Light microscopes only give us a 2D image, the laser scanning ones give us 3D. They have the same magnification at about times 1500, and the resolution is slightly better on the laser scanning one at 160 nanometers, but only 200 on the light microscope. Both of them can be based on living specimens, and the light microscope is obviously in 2D. The laser scanning microscope gives us a 3D image. The electron microscopes use electron beams. The scanning electron microscope gives us a 3D image, whereas transmission is only 2D. But the payoff for this is that the scanning electron microscope has a low magnification of 200,000 compared to 2 million, and it has a resolution which is higher of 20 nanometers compared to a much better 0.1 nanometers. Of course, they're both coated in metal and put into a vacuum, so the specimens are always going to be dead when they're viewed. So, in summary, electron microscopes use a beam of electrons instead of the light. Scanning electron microscopes can represent 3D specimens. Transmission electron microscopes can only represent in 2D, and in electron microscopy, samples are dead and they have to be stained or coated with a metal. Thank you for watching.